All right, I appreciate this opportunity to speak to you about NASA's Technology Transfer Program. So what we're about is there's lots of people that work at NASA, our employees and our contractors, and they're constantly working on technology. John mentioned a lot of the projects that go on there. And so what we're doing in tech transfer, it's a congressionally mandated function. All federal laboratories are required to kind of capture inventions that they think that people outside the laboratory could use for multiple purposes. So we spend a lot of time working with our employees, trying to get them to tell us about new things they've invented, and then we look at that and we say, hey, could somebody in some other industry or some other application other than space repurpose that technology and use it for something else? And so I've got some slides here. I can see. Oh, there we go. Like I said, this chart I won't spend any time on. I'm just going to tell you that we're like I said earlier, we're a congressionally mandated function at every federal laboratory across the U.S. government. We've all got patents. We've all got technology. We're looking for companies to use this technology and find some other purpose for it. Our process, I won't spend a lot of time on this either, but I want to show you that, so like I said, we're trying to get our inventors to tell us about things they've created. Some of that stuff we patent, and we look at, is it legally patentable from a legal point of view? Does it have commercial potential? Would somebody want to pay us to use that technology within, say, the next 8 years? And the reason I say the next 8 years is patents have a 20-year lifespan if you pay all their maintenance fees. The first maintenance fee is at 4.5 years, and the second maintenance fee is at 7.5 years. And then the third one's at 11.5, and they go up in cost. So we're kind of looking at an 8-year window, before we patent something. So our patent attorney patents it. We start marketing it. We try to find companies through a variety of ways that would use our technology and find some way to, use it to solve some cool problem. And I'm going to give you some cool examples of that very soon. So the end product, what we're really after is we're trying to show people you get more than the rockets and all the cool science at NASA. You also get all these cool inventions in your life, and we call those spinoffs. And we document that every year in a book and on our website. There's over 2,000 of these spinoffs since 1974, I think. And there's 50 or so we document every year in the book. And the royalties we collect, we typically give that money, most of that money goes to our inventors. We're trying to incentivize them to innovate. We're really just trying to recover our patenting costs. It's more of a, trying to make sure that we keep people incentivized in finding new things. Let's see, next chart. So I'm going to give you some examples of some cool spinoffs from technologies developed here at Marshall in Huntsville. But before I talk about these, I'll talk about one that probably NASA's greatest spinoff that many people don't know what it is. It's the CMOS technology, the camera on a chip technology that is the basis of all digital cameras, all cell phone cameras, all dental imaging, lots of things use the CMOS. And that was invented by Dr. Eric Fossum at Jet Propulsion Lab about 20 years ago. He was working on the Cassini mission. He was trying to find a lightweight, small power usage camera imaging capability that could work. And so he invented it, had several patents, formed a company. The company was bought, and eventually, CMOSs have improved clearly over the last 20 years, but the original patents and the work there by Dr. Fossum was the basis of all your current digital imaging capability. So few people realize that, and that's one we're trying to get the word out about. And I'll hit a few other ones here from here in Huntsville. So if you look at the escalators there in the middle, so we had an inventor. His name was Dr. Frank Nola. He worked at Marshall in the 80s, and he was trying to solve some problems on trying to make electrical motors more efficient. And he came up with a device that basically scaled the energy consumption of an electric motor with this thing he called a power factor controller. And so he invented this thing in the 80s. It was eventually adopted by many. So basically all your escalators and elevators, when they were first out there, when people were on them or not on them, they used the same amount of energy. Well, with his power factor controller, they could scale their energy usage based on the load. And so that device is now ubiquitous. It's everywhere. And that was one of Marshall's probably biggest spinoffs from the 80s, I would say. And moving into the 90s, the picture below is a picture of Paul Meyer and Dr. David Hathaway. They invented a algorithm called Visar, and what it did was clean up solar flare imagery and make it very crisp. And so the way their algorithm got used was back in 1996 at the Atlanta Olympics. There was a bombing that took place there, and there was some grainy video. Somebody put a backpack under a table in the Centennial Park area in Atlanta, if you've been there. It was a big mystery. They falsely blamed a security guard for it at one point. He was the guy that actually found it and reported it. And then it turned out it was, I think Eric Rudolph was the guy that was finally convicted there. But the imagery was cleaned up for dark. They were able to clean up the imagery so they could get identifying features of the person that was involved. And then that technology was licensed here by a local Huntsville company, Intergraph, now named Hexagon. And Intergraph, for a number of years, sold a product to every police station across the United States, and I think even internationally, that used the Visar algorithm to clean up video. And our inventors were a part of many trials where they were expert witnesses about cleaning up video. So again, a NASA technology repurposed. This one for heliophysics has now been repurposed for cleaning up video for crime situations. I'll now move to the boat motor you see there on the left. That's from the 2000s or mid 2000s. We have an inventor. His name is Dr. Jonathan Lee. He's a master metallurgist. He has about 13 different patents in all kinds of aluminum alloys. He knows how to mix them in certain ways to make them, for different properties depending on the application. And so he had an alloy that had a high strength and high wear resistant capabilities. And we started working with the Bombardier Corporation, Bombardier Recreational Products, the Evinrude outboard motor division of them. They were desperate to find an aluminum alloy that would work as a piston in their E-Tech boat motor line. So since, I think, 2004, over 700,000 boat motors have been sold that use our technology as the piston. And Jonathan has many more alloys. We'd love to find somebody that has a problem that needs high strength alloys or various different properties. We got that. And the last one I'll mention real quickly is the fluid damper technology we developed very recently. And Rob Berry is one of our employees there at the center. We had a rocket problem that had a vibration issue, and we were worried that the astronauts' eyeballs would go into resonance on a previous rocket program that has since been canceled. And we had to come up with a solution without adding weight to it, or a lot of weight, because rockets, the payload is everything. You don't want to do anything that decreases the amount of payload you can take to orbit. So we had to find lightweight solutions. And so those guys leveraged the fluid in the upper stage of that rocket and managed to shake that fluid in a way that would counteract the vibration that was going on from the burning of the first stage. So we applied that same concept to buildings. And so we talked about hurricanes and earthquakes, things that, natural disasters. We have a technology now that's installed in a building in New York City, in Brooklyn, right next to the Barclay Center. It's called the B2 building. But that technology is a series of water pipes on top of the building that counteract vibration due to wind-induced resonance. So it's more effective than anything that's been used before, and it's an order of magnitude cheaper in cost. So those are 4 examples there of just real-life spinoffs from Marshall, and every NASA center across the country has got some. We've got about 1,400 patents for licensing, and you can see them on our website, technology.nasa.gov. Sensors are our biggest category, and so are materials and coatings. We have a special startup license. It's free for a non-exclusive license up to 3 years, and we'd love to talk to you about that if you find a patent that you want to use. Our key takeaways: 1,400 patents. We have 1,000 free software codes you can look at too. These are tools we developed in-house at software.nasa.gov. And maybe you'll find a technology you need to do as you're working on your problems this weekend. And we'd love to talk to you about that.
Time for some Q&A. So if anyone would like to ask a question, now's your opportunity. I'll come around with the microphone. Takers? Any takers? Anybody in the back? All right. Oh, here's one right here. Would you mind saying your name and stating your question?
Robert Pat Lefany. I was wondering about the free software tools. Can anybody just use those out of interest, or do you have to be part of a government or corporate environment in order to qualify for the license on these?
Yeah, it depends. There's a variety of codes in our software catalog. Some of them are open source. Anybody can use them. Some of them are public release. But we certainly have some that are government use only, where you have to be on a contract. So it says on the code what that is. Some of our trajectory codes would be ones that are restricted. That's a determination we go through about ITAR and things like that. But we have a number of codes that are open source that are available to anyone. One thing I meant to mention is we have a remote sensing data kit that we just put out there. It's on our website, technology.nasa.gov. There's a link to that, kind of describes what it is. I think with the theme of today, that may be something that you guys are looking at, might be very useful to you.
Any other questions? It's a great opportunity. All right. We got another taker.
All right.
Hi, I'm Stephanie Bastians. In light of all of these really interesting patents and everything that NASA's helping to develop, is there anything that stands out to you in the realm of sustainability and just in general having more renewable energy and just helping kind of fight all the pollution that we have, building up in our oceans, and just this deep need to change the way we're building, manufacturing, and really consuming?
Wow, great question. We certainly have technologies in our environmental area where, it can take various different forms. Again, the way our technologies come about is somebody has been working on some NASA problem, and then we're trying to find if somebody else could use that technology in a different way. We have a lot of environmental remediation technologies that our Kennedy Space Center has developed that help clean up. They had some, for all those rocket launches down there, they've got lots of, there's been some contaminants that had to be cleaned up, so they developed technology to deal with that. One of the same fluid damper technology I was talking about earlier, we've been using that to, we just finished some testing where we had floating wind turbines out in the ocean. We were testing with the University of Maine, and we were testing the ability, so that people are trying to put wind farms out in the ocean, and they're putting on these big barges, and so they're worried about waves, and resonance and shaking things apart, and we just proved that our fluid damper technology could be used to stabilize a wind platform out in the ocean. We did it at a scale level on a simulation of the ocean that they have at University of Maine, a wave energy pool. But that's a cool technology that certainly has applicability to sustainability and that sort of thing. We'd love to find a wind turbine manufacturer that would love to use that, and we just have data recently on that. So,
No questions?
So in this kind of changing world of how technology is integrated in everyday life, how do you see, or what's your vision of how the tech transfer will be changing in the near future?
Well, we're constantly finding ways to get the word out. A lot of people don't even realize we exist, and we've been around with NASA since the beginning of NASA, 1958. So we're utilizing social media, and we're using different ways of trying to get the word out to people, go to trade shows. Our technology, it's constantly evolving. We're always trying to work with our inventors that invent things and try to, get those out, identified, and, out to the community, make them aware. We're trying to find, target-rich environments, we call them, where lots of people that do a certain kind of work are come together and try to make sure they know about us, and we do a lot of marketing that way. But we certainly are trying to leverage all the technology that comes out of NASA. I'm constantly beating the bushes at the center, trying to find, telling people about the opportunities we have at Tech Transfer, and that, all the cool things we can do with their technology if they'll work with us. So.
More questions? Anyone on this side of the room? Down in the front. Okay.
Hi, I'm Brianna Lane, and I just had a quick question. You said that this weekend we could possibly use some of the technology. Is that true? Or I'm sorry if I misunderstood what you were saying.
Well, certainly, if you're looking for technology to solve a problem, we have solved a lot of problems with our technology. I don't know if it'll solve your problem. The way you could use it is you would. I don't know what level y'all are going to get to today or over a weekend, but you could certainly find out about the technology. We have information sheets about all of our patents. You can search our website at technology.nasa.gov in our patent portfolio, and we'd be glad to talk to you about it. As far as it would probably, a lot of it is, if you want to get really detailed information about our technologies, we'd probably have to wait till next week sometime to talk to people about the inventors that do the work. But certainly you can look on our website and identify technology that may be useful to you and see how you could employ it.
More questions? Toward the center.
Hi, Quentin Cormete.
Yes.
I'm just thinking if a private company has what might be a good, worthy patent for NASA, and they already have a patent, but it needs developing, would that be the sort of thing that that company could go to you and say, you guys are the experts in that field, but we have something that needs further development to make it a workable thing? How would that go down?
Yeah, so there's several avenues there. Tech transfer typically is not, we do not get involved in that, but there's a partnerships function at NASA. Every NASA center has a partnerships group, and they are, you could certainly bring your technology to them, and they would find people if there was a mutual interest. There may be a way to do that. We also have something called the Small Business Innovation Research Program, Small Business Technology Transfer Program, and there's money out there every year in a phase 1 or a phase 2 contract. That solicitation goes out in January of next year, and it'll be a call for proposals in technology areas that we think that NASA needs to support its mission. You could certainly propose your technology if you find a fit with one of those, and the phase 1 can get up to $125,000. Phase 2 up to $750,000 over a 2-year period. And then there's also the possibility of phase 3 where some NASA mission says, hey, that's a cool technology, I want to use it in my mission, and they can fund it directly, sole source. So that's one of the great things about once you win a phase 1 or a phase 2, we can, any government agency can award a sole source phase 3 contract to you if they have money, if they have a need. So certainly look at sbir.nasa.gov, and that lists our solicitation and all our topics. And love to, and again, our partnerships group looks at joint agreements called Space Act agreements. If there was a mutual interest where NASA thinks that we could co-develop something on something that helps us, helps you. We have those kind of agreements available too. And I think it's partnerships.nasa.gov is the website for NASA partnerships.